So, good morning, everyone. Welcome and thanks for being here for the space debris session. I'm today, due to unexpected difficulties, Michael cannot attend in person with us, so he's online, and I will have the pleasure to share the desk with Van. So, without further ado, I will introduce André Cloth in behalf of Martin Ploner, that will talk about the space debris laser ranging, challenging and rewarding update of the Izaña station. André, the floor is yours.
Thank you very much. We had already a few presentations about Izaña-1 station, the current status, and now just recently a new project started with an upgrade of the station. Just to introduce you the team here briefly, we have a team from DiGOS. Our project manager cannot make it here, so it was planned that Martin Ploner holds this presentation, but not possible today. We have a GMV team from Spain, who's our prime contractor in this overall activity, ESOG, and we have a team from the Space Research Institute from Graz. This one. The activity is called Laser Ranging Evolution towards Active Sensor Networking for Debris Observation and Remediation. In principle, it consists of two parts. One is the upgrade of the Izaña-1 station, which I'm talking about here, and the other is what Tim already mentioned in his talk. This is the networking approach, how we in the future deal with collaboration of different stations, how we exchange information to make it like a service that you can more rely on, that is in a collaborative approach. Our teaming, GMV from Spain is the prime contractor, and you have here DiGOS, IWF, and Libre Space Foundation as team members. Well, just to recap the status quo, we have SLR stations, so for cooperative target in place. We can do already laser communication with that station, and what we also can do is passive optical space debris observation. As you can see on the upper right picture, there is this metal extension. There is a space debris camera that was already in the very first project when we created and developed the station. This was added, and we are now started using it. The basis is an 80 centimeter alt-azimuth telescope with two Nasmith foci on the side, and we have two optical ports, or some called also Nasmith foci, or folded Cassegrain foci on top, on the bottom of the main mirror cell. We use them for the laser ranging detector package on the one side, for the optical communication terminal on the other side, and the top one for space debris. So we still have one free. From the design, this is a piggyback configuration. This is, let's say, the starting basis for our activity. The extended functionality we are aiming at is laser ranging to uncooperative target, what we typically also call space debris. So not all uncooperative targets are debris, but you know that probably. Let's say one challenge here is that we try to go for day and night debris or uncooperative target observation. We are going to do light curve measurements and implement a stare and chase mode. This is already quite some work to do, and I would say from research towards such a activity that we promise to ESA quite challenging, but we add something on top. This is the full automation of 4 different operation modes for SLR, SDLR, the space debris laser ranging, light curve recording, and stare and chase. On the picture you see the small green circle. Keep this in mind. This is on the next slide. there are different ways to extend the station by space debris laser ranging, and we decided to go for the split configuration. Maybe just on the requirements and the goals we have for the debris laser ranging is in the nighttime we are aiming at 10 centimeter objects up to 600 kilometers, the 50 centimeter objects up to a higher LEO orbit, and the rocket bodies we are trying to observe up to 3,000 kilometers. And during daytime we try to see the 50 centimeter objects up to 1,000 kilometers. Here you have a plot without going into the detail of the link budget calculations. This was, let's say, the basis of the decision how to do the upgrade in terms of components. So we made up our mind how to do it. I mean, we come from, together with the colleagues from Graz, from the piggyback design of laser ranging stations. But here we have a slightly bigger optics, slightly bigger laser. So we decided a good approach is to go for a split configuration. That's how we call it. So we are going to build a separate cylindrical section with a dome, with a mount, and put the laser package, how we call it, with a separate optics on that mount and control it independently. We will use an additional guiding refractor to do, for example, stare and chase, and also, optical guidance, because the one point is the predictions are so far not always in a quality that you can do blind tracking with space debris. Interesting thing maybe for you, if you consider something like this in the future, this design, of course, you see it immediately can be used to extend existing stations as well. So this was also the case why we decided to go for this. Few words for the laser package. Of course, it's a separate housing. We protect it against environmental heat or whatever comes, non-operational environmental conditions. We have a high power laser. You see the specs here. It's a 40 watt laser roundabout. We are only using the near infrared wavelengths. This is also a lesson learned in the SLR operation, that you have less noise in the near infrared. The bandwidth we are doing for day-to-day operation on Tenerife. The very classic approach, I would call it. You have read similar laser configuration in other papers already over the years. Additionally, to give you an outline of the hardware components, besides the cylindrical section, we have an upgraded range gate generator that is space debris optimized, in a sense that we can use longer gating times. Some timing effects or issues can be avoided with that. And we will add an aircraft detection unit that also supports visual detection besides the existing ADS-B detection. The laser package, you might know this conceptual or schematic drawing from the detection package already from previous presentation. IWF was kind of already looking into the future when they designed the package, so we have the option here to add the light curve detector. This we will do in that activity, and additionally measure the light curves. One point is that I said we have to do the optical guidance, and we have in principle two different conditions. This is one is the nighttime and one is the daytime guidance. So for the bigger objects and when they are illuminated, the right one, more sensible, is essentially for the daytime observations, but cannot be used simultaneously because we are using as I introduced, the existing space debris camera on the big RX receive telescope, and feed the information for residuals into the satellite tracking and then into the space debris laser ranging. Whereas here we use from the TX, the sanding telescope, a camera in that package that has only an optics of around about 20 centimeters. I cannot say exactly that it will be 20 centimeters. We are in the design phase so far, which will be closed until hopefully end of this year. But to give you an idea, this of course has a much cannot directly be used for daylight, where we need higher sensitivity. But at the end we have corrections and we apply them for the debris laser ranging. One last point I would like to mention is that we also upgrade the laser safety subsystem. I mean, the laser we have for cooperative targets is also not eye safe, but here it's even worse. We have higher powers, so we have to follow laser safety standards, and we will put in place with our existing laser safety unit this aircraft detection unit for thermal infrared. There is an activity, an ESA activity ongoing, where we already developed such a box with different cameras for different wavelengths. One of that is the thermal infrared, and well, here you see a preliminary result that will be presented today in the session by Hritik Pandey with the detection of an aircraft or whatever flies around and is potentially can be hit by laser. We have an automatic cut of the trigger line or the interlock of the laser. So all this is needed when we are going to do automated operation also in the future. That was the overview, and I hope in maybe 1.5, in 1 year, at the end of next year, we will do the first testing on Tenerife. The whole project is planned for 2 years, so expect the first rumors maybe end of next year and the first public presentation maybe the year after. Thank you.
Is there any question or comment for André?
Andre, have you taken the images with the space debris camera and look at the centroid of those images and then compare to laser-generated orbits? Do you see any kind of similarities or differences with respect to what you see?
So with the existing camera, I know that we are more or less on a regular basis take pictures just to have a reference what we can expect from the existing camera. But I don't know how it's exactly used at the moment for orbit predictions or plate solving or whatsoever. So this is maybe you can ask Sven, our colleague who is supervising the observation activities at DiGOS. So we operate the station for ESA as well. Have a team that is led by Sven. Maybe you go with a question to him to see what's the preliminary results.
Is there anything from audience? Okay. Otherwise, there's a question from online, also from Michael Steindorfer. He should have been the chair here. And could you please elaborate a little about the necessary communication between the two slit parts of the station?
Pardon, the last part, the communication between?
If I understand correctly, he's asking about you would like to hire another new telescope for transmitting, for debris tracking, and take the current station for receiving. This is split, two split parts of the station.
And what's the question? So we come from a similar configuration in Potsdam. Maybe to say this, we have bistatic, or GFZ has a bistatic system, so it's for us in Potsdam quite common to have this separate TX and RX system. On the opposite, we were surprised that most of the world is doing laser ranging only with one mount, let's say.
Thanks. Okay, otherwise we move to the next one. Thank you, Andre.